In the last video, I discussed how to construct the optimal tree and also we calculated the weight for that optimal tree. And here we are constructing the optimal prefix code. We are calculating the optimal prefix code by constructing the optimal tree. And let's see how to construct the optimal prefix code for the given symbols. Here, the procedure is same. We will construct optimal tree first, and after that we will drop all the weights of the leaf node, and the children were assigned with the values zeros and ones. That means the left child will assign with the value 0 and right child will assign with the value 1. Consider the example, and as usual we are arranging them in a ascending order. So Q is having a minimum weight 4, and next we have Z with the weight 7, Y with the weight 12, and U with the weight 17, A with the weight 20, and finally we have O with the weight 28. Now we did the arrangement that is in ascending order. Again, we need to add the two minimum weights, that is QZ is having minimum weight 4, 7. Hence, we need to add them and assign to the new vertex. So here we will consider the new vertex as B1, and we are adding the two minimum weights as, that is Q and Z, Q with the weight 4 and Z with the weight 7, and we are going to get the weight as new weight as 11. And again, at the same step we need to make a arrangement, that is we need to arrange them in an ascending order. Here 11 is the minimum value, so it will be retained as usual. So Y with the weight 12, U 17, A 20, O 28. In the same step only, I would calculate the minimum weights, and also I'm going to make an arrangement in a ascending order. So the next two minimum weights are 11 and 12, and we need to add 11 and 12 and assign to the new vertex, and the new vertex is V2. We are adding and it is branched. So here V1, we are adding V1 and Y. So we will get it as V2. So V1 again, it is, if it is retained the previous structure, then V1 having weight 11 and Q 4, Z 7, and with the V1 we have added Y with the weight 12. By adding 11 and 12 we are going to get the value as 23. This is the new weight we are getting, and again we need to make a arrangement. Here in the previous step 17 and 20 are less than 23, hence we need to write here, that is U value 17 and A value is 20. Next we have V2 and O 28. 17, 20, 23, 28. So next the two minimum values are 17 and 20. So let's add that 17 and 20. So assign that to the new vertex B3. So U with the weight 17, and next we have A with the weight 20. These two are the minimum values we are adding, and if you add that we will get it as 37. And again we need to make a arrangement. Here we have added 17 and 20, and remaining vertices V2 and O are having a weight 23 and 28. By adding 17 and 20 we are going to get it as 37, whereas this 23 and 28 are less than 37. Hence we are going to write here, that is B2 with the weight 23. Sorry, Here I'm going to write V2. V2 with the weight 23. And here it is V1 11. Q, we need to retain the structure 4, the previous structure 4, 7, and here Y is 12. And next we have the value O, that is 28. We did make a arrangement 23, 28, 37. And as comparison, we have the two minimum weights are 23 and 28. Now we need to add them. So by adding 23 and 28, we are going to get the new vertex. V2 is over, V3 is over, V4. So we adding 23 and 28. So V2 is having 23 and the corresponding descendants are as follows. V2 and here it is Y with the weight 12 and here we have V1 11. This retirement of a structure is very important. Z 7. Yes, here the V2 tree, V2, V1, Y, Q, Z is over. And next we are adding 23 and 28, right? So we added 28, that is O. So by adding 23 and 28, we are going to get the value as 51. But 51 is greater than 37, hence we need to make arrangement. We need to bring V3 here. So V3 is U, that is 70, and A, that is 20. B3 value is 37. So finally, we left off with B3 and B4 with the corresponding weights 37 and 51. We need to add them, 37 and 51. So here I'm going to write. Finally, you will be having the structure, and at the final stage, we need to assign it as a root node. And here we have V3 and V4, and again it is branched as so. Here R value it can be get by adding the two weights 37 and 51. So V3 37, retain the structure U 17, E 20, and next V4. V4 is 51, and we have V2 23, O is 28, and V2 is over. This here it is the weight Y with the weight 12, and V1 11, Q 4, and Z is 7. Don't get the confusion. You just retain the previous structure. That's it. By adding these two, 37 and 51, we will get the value as 88. Finally, we will get the weight as 88. And here we are not going to calculate weight of the tree, weight of the optimal tree. Instead of that, we need to calculate the prefix code. Hence, we need to drop all the weights. We need to drop all the weights. But instead of that, we are going to assign the left node with the binary value 0 and right node with the binary value 1. Then the resultant structure will be like this. The same tree I'm considering, but I just drop all the weights. I'm not going to indicate the weights. Instead of that, I'm just considering the tree structure. I'm just considering the tree structure. And here it is the root node, and the left child will be assigned with value 0, and the right child is going to assign with the value 1, and here also it is 1, here it is 0, 1, 0, 1, 0, 1. So finally we are going to get this structure, and let's label them. See, this diagram only, this tree structure only, I have written over here by dropping all these weights. I just retain with only the labels U, A, Q, Z, Y, and O. And left side child are left child assigned with 0 and right child assigned with 1. So this is called as Huffman tree. Huffman tree, or it is a optimal tree. Optimal tree. Now we need to make a, or we need to write a code for a corresponding labels. A, how you can reach A? We need to start with root. So 0, 1. We need to reach A by traversing 0 and 1. Hence the code for A is 0, 1. Next we have A is over. Next let's consider O. How to reach O? We have start with root. We can traverse 1, 1 so that we can reach O. So the code for O is 1, 1. Next we have Q. So from starting with the root, we will reach Q via 1, 0, 0, 0. So code for Q is 1, 0, 0. And next we have U. U can be reached, start with the root 0, 0. So code for U is 0, 0. Next we have Y. So here it is Y. Y can be reached, start from root 1, 0, 1. Hence the code for Y is 1, 0, 1. Next finally we left out with Z. So how we can reach Z? Start with root 1, 0, 0, 1. Hence code for Z is 1, 0, 0, 1. So these are all the prefix code we are getting for the corresponding labels. So here this is also same as construction of optimal tree, but instead of calculating weight of the tree, here we are dropping the weights. Instead of that, we are assigning the left node with zeros and right node with ones, and finally we are writing the corresponding codes. This is how we need to calculate the prefix code. Same way, the same prefix code can be calculated for the message as well. So what you are going to do in the case of message, you write all the appearing alphabets and also write how many times that alphabet are appearing and consider that frequency as a weight, and then we can construct the tree. For that you just go through the nodes, and here the space also in the message, the space also considered. For example, the message we have ROAD, road is good, and here R is appeared only once, so the frequency or weight for R is 1, and next O is appeared thrice, so 3, A is 1, D is 2, and we have a space. That space can be represented like this, where space is 2, I is 1, S is also 1, and G is 1. So this is how you need to assign the or convert them into the weights, and finally follow up the same procedure so that we can calculate the prefix code for the message also. Okay, thank you.